From H.G. Wells's Time Machine to Doctor Who's adventures, the idea of time travel has excited us for a long time. These stories have captured our imaginations, making us wonder about the endless possibilities that lie beyond the constraints of our current reality. They invite us to dream of worlds where the past, present, and future are all accessible, where we can rewrite history or glimpse the unknown. We dream of escaping time, visiting the past, or zooming into the future. The allure of stepping into a different era, witnessing pivotal moments, or exploring futuristic landscapes is a powerful one. It's a testament to our innate curiosity and our desire to transcend the limitations of our existence. But is time travel just a fantasy, or could it be real? This question has puzzled scientists and philosophers alike. The complexities of time, with its seemingly linear progression, make the concept of traveling through it both fascinating and perplexing. Could there be a way to bend or even break the rules that govern our perception of time? It might sound like science fiction, but what we know about the universe hints that time travel might not be so crazy after all. Theoretical physics and cosmology have opened up new avenues of thought, suggesting that the fabric of space-time is more flexible than we once believed. The idea of time travel is actually hidden in the laws of space and time. These laws, governed by the principles of relativity, suggest that under certain conditions, the flow of time could be altered. This opens up a realm of possibilities that challenge our conventional understanding of reality. To understand this, we need to explore the universe, following Albert Einstein's brilliant theory of relativity. His groundbreaking work has provided us with the tools to imagine a universe where time travel is not just a figment of our imagination, but a tantalizing possibility waiting to be unlocked. Einstein's theory of relativity changed how we think about space and time. He combined them into one thing: space-time. Imagine a giant, four-dimensional sheet where everything in the universe happens. This sheet isn't flat, it can bend and stretch because of heavy things and energy. Think of a bowling ball on a trampoline. The ball makes the trampoline dip down. Similarly, heavy things like planets and stars make curves in space-time. This curve is what we feel as gravity. It's not a magic force pulling things together, it's the curve of space-time telling things how to move. One amazing part of Einstein's theory is that time isn't the same for everyone. This concept, known as time dilation, is one of the most fascinating aspects of modern physics. Time doesn't move at the same speed for everyone. It depends on how fast you're moving and how strong gravity is. The faster you move, the slower time passes for you compared to someone who is stationary. This phenomenon is called time dilation. Imagine two identical clocks, perfectly synchronized. One clock stays on Earth, ticking away in a normal setting, while the other is placed on a fast-moving rocket and launched into space. According to Einstein's theory, the clock on the rocket will tick slower than the one on Earth. This isn't because the clock is malfunctioning, it's a natural consequence of how time works in our universe. This isn't just a theoretical idea. Scientists have conducted numerous experiments to prove time dilation. For instance, they have synchronized atomic clocks and flown them on airplanes. When these clocks return to Earth, they show tiny but measurable differences in time compared to clocks that stayed on the ground. This proves that time dilation is a real effect. Clocks on airplanes, for example, show tiny but real-time differences compared to clocks on Earth. This effect is even more pronounced for astronauts. Astronauts on the International Space Station orbiting Earth at high speeds age a little slower than us on the ground, though the difference is just by a tiny bit. This fascinating reality shows how interconnected time and space truly are. Time dilation makes time travel to the future seem possible. This fascinating concept is rooted in Einstein's theory of relativity, which tells us that time is not a constant. Instead, it can stretch and compress depending on how fast you are moving relative to something else. This means that the faster you go, the more time slows down for you compared to someone who is stationary. The faster something moves, the slower time goes for it compared to someone who is not moving. This effect is incredibly small at everyday speeds, like driving a car or flying in an airplane, but it becomes much more noticeable as you approach the speed of light. If we could go almost as fast as light, time dilation would be much stronger. In particle accelerators, particles are sped up to nearly the speed of light, and scientists observe that these particles experience time much more slowly than we do. Imagine a spaceship going 99.99% the speed of light. At such incredible speeds, the effects of time dilation would be extreme. The crew on board would experience time at a fraction of the rate that people on Earth do. It travels to a star system 100 light-years away. To the people on Earth, this journey would seem to take just over 100 years, as light from that distant star system takes that long to reach us. People on Earth would see the trip take a little over 100 years. However, for the crew on the spaceship, the experience would be vastly different. Due to the effects of time dilation, they would age much more slowly. But for the crew, time would slow down a lot. While a century passes on Earth, only a few years might pass for them. This means that when they return, they would have aged only a few years, while everyone they knew on Earth would have aged a century. A few years for them would be a century on Earth. This dramatic difference in the passage of time is one of the most mind-bending aspects of time dilation, and highlights the strange and wonderful nature of our universe. When they come back, they would have traveled to Earth's future. They would find a world that has changed significantly, with new technologies, cultures, and possibly even new challenges. This is possible in theory, but building a spaceship that fast is really hard, and we can't do it yet. The technological and energy requirements are beyond our current capabilities, but the concept continues to inspire scientists and engineers to push the boundaries of what is possible.